Hi. Previously, we talked about the curtailments of reinforcement bar in simply supported beam. Today, we're going to talk about the curtailments of reinforcement in the continuous beam based on the simplified rules as demonstrated by the diagram here. These rules you can obtain from the British Standard Act 110, figure 3.24. Which according to the rules for the continuous members, these are the requirements for the top reinforcement, where you may reduce 40% at certain distance from the support and another 40% at another distance. As for the bottom steel bar, 100% reinforcement will be at the midspan. Near to the support, you may reduce the amount of reinforcement bar to 30%. Bear in mind that there are conditions for you to use these simplified rules for beams, which is clearly stated in the British Standard. First, you need the beam to be predominantly uniformly distributed load. Second, if you are dealing with continuous beam, the span should be approximately equal. These two requirements must be fulfilled so that you can use these simplified rules for the design of the reinforcement. In case that these two requirements are not fulfilled, you can still do the curtailment, just that you need to use the fundamental approach, either by using the simplified method or the Eurocode method. Just that both of these fundamental methods are rather tedious. Both of these methods we have discussed in our previous videos. Today we're going to focus on doing the curtailments of the reinforcement bar for the continuous beam using the simplified rules. You know that these simplified rules serve as the guideline for you to determine where you can curtail the reinforcement as well as how much reinforcement that you need to provide at different locations of the continuous beam. The final detailings of the reinforcement might not be exactly the same as per the simplified rules given in terms of the exact dimensions where you curtail the reinforcement, as well as the amount of reinforcement bars at different places of the continuous member. It is subjected to adjustment depending on different circumstances. But you need to make sure that the minimum amount of reinforcement bar as per specified must be fulfilled. Among other considerations which may influence the final layout of the reinforcement include the minimum bar spacing, symmetrical reinforcement bar arrangement, minimum bar curtailment, and also the length to be rounded up to 25 mm. Why do you need to round up the length into the nearest 25 mm? This is because in the local industry, the workers still abide to the imperial units. However, when we design, we use the SI unit. For easy conversions, 1 inch is about 25 mm. Therefore, when we design the length, measure we round up to the nearest 25 mm so that the workers on site can do the direct conversions. Having this established, now let us look into the example. Given a continuous member here, the beam span is 6 meter and the cross sections of the beam it would be 175 times 600. Let's say you have designed the reinforcement bar for the beam. For the bottom reinforcement bar at the midspan, it requires 2T25. As for the top reinforcement bar at the support, you require 3T16. From there, you will need to work out the final layout of the reinforcement. First of all, you will need to check for the minimum bar spacing. It is given the cross sections of the beam with the width of 175 mm and the height of 600 mm. The bottom reinforcement bar at the midspan is 2T25, whereas the top reinforcement bar at the support is 3T16. We first need to check if the minimum spacing is fulfilled based on the proposed arrangements of the reinforcement. As in this location represent the full 100% of the reinforcement. And then after the curtailment, the amount of reinforcement bar should theoretically be reduced. Therefore, we're going to check the minimum spacing available within the reinforcement. First, let us deal with the bottom reinforcement bar here. With the given width of 175 mm minus the cover from both sides, which in this case is 35 mm, minus the shellings from the both sides, which is 6 mm, and then minus the two tension reinforcement bar, which in this case is 25 mm diameter, as indicated by the calculation here. The spacing available between the reinforcement bar, it will be equals to 43 mm. Now let us check the minimum spacing required. It is determined by the bar diameter, the aggregate size plus 5 mm, and also a minimum of 20 mm. The bar size now is 25. Aggregate size 20 plus 5, which is equals to 25. And then a minimum of 20 mm spacing. We will take the biggest value of the three that give you 25 mm minimum required spacing. Compared with the actual spacing, the actual spacing is greater than the minimum spacing. Therefore, this arrangement of the reinforcement bar is acceptable. Next, we're going to check the top reinforcement. We will do the same for the minimum bar spacing, only this time the bar size is 16. We will take the largest value of the three that give you 25 mm also. Now we're going to calculate the spacings between the reinforcement. 3 units of 16 mm diameter bar are arranged. In order to get the actual spacing, we take the width of the beam minus the cover from both sides, which is 35 times 2, minus the shelling from both sides, which is 6 times 2, minus 3 units of 16 mm diameter bar, which is 3 times 16. There are two spacing here. That's why the entire calculation here need to be divided by 2. The actual spacing is 22.5 mm. This is slightly smaller than the requirement of 25 mm. That means the requirement for the minimum bar spacing is not fulfilled. In another word, you cannot have 3 T16s arranged as the top reinforcement bar at the support. You will have issue when you do the concrete casting. That aggregate might stuck and not being able to pass through the spacings of the reinforcement. In order to overcome this issue, you will need to modify the arrangements of the reinforcement. Now, one principle of arranging the reinforcement is that you will have to have the reinforcement arranged in the symmetrical manners. You cannot simply move the 1T16s here or here. That will give you unsymmetrical arrangements of the reinforcement. You have two options here. Either you increase one reinforcement bar with 16 mm diameter, make it an even number, so that you can have one reinforcement bar here and another reinforcement bar here without having the center reinforcement. This gives you a symmetrical arrangement of the reinforcement. Or you may enlarge the bar size so that you will have less number of reinforcement bar, end up with an even number. Then you can arrange the reinforcement bar in the symmetrical manner as well. Now, these modifications, it will be on the basis that you don't compromise the amount of reinforcement bar required here. You can provide more, but you cannot provide less. How do we actually do it? You may refer to the tables of the reinforcement bar area here. 3 units of T16 reinforcement bar give you a total area of 603 mm square reinforcement bar area. If you choose to have an additional reinforcement bar, your total area it will be equals to 804 mm square. That will give you 4016 here. Or you can choose to enlarge the size of the reinforcement bar. Instead of providing 16 mm diameter, you provide 20 mm diameter. You will get slightly larger area of reinforcement.